Hello, and welcome to Autology, the podcast that brings you the latest on automotive technology. This week's episode is called Caught in the Act Securing Raw Materials in the EU. And you're here with me, Elisha Thakorlal, and S&P Global's propulsion expert, Peeyush Garg, alongside battery expert, or as we've come to know them, our batsman, Ali Adim. Hello to you both, and thank you for joining another episode of Autology.
Hello, Elisha. Thank you for having us.
Hi, Elisha. Good to be here.
Great. So today we're discussing the EU's Critical Raw Materials Act that was proposed back in mid-March. But before we get into the implications of it on the autos industry, could you briefly describe what the act is, Ali?
Yeah, sure, Elisha. So, in essence, Europe wants to reduce the risk associated with the supply chain of some selected critical raw materials. And they have proposed various solutions in order to achieve that. For example, they want to promote the local production of these materials. They want to facilitate the European projects, reduce the monopoly of some countries over the supply chains, like China, for instance, and also improve the visibility and controlling of the strategic stocks. Probably the most important part of this legislations are the targets that are defined as the benchmarks for the localized extraction, processing, and recycling of what they call strategic raw materials. I read to you some of these targets. At least 10% of EU's annual consumption for extraction should be coming from Europe. As for the processing, 40% of annual production should be from localized sources and 15% for recycling. Moreover, no more than 65% of the union's annual production, annual consumption for each strategic raw material should come from a single third country. And there are also some proposals on how to achieve these targets. For instance, some projects will be defined as strategic and private and public funding will be facilitated for those projects.
Right. So companies or OEMs will receive funding or maybe even like a grant of some sort for complying with the act. Will there be any other benefits from this legislation besides a financial reward?
Yeah, for instance, there are considerations to fast track the permitting of strategic projects. Under this new proposal, the time that is needed to get the permit for the extraction projects will be reduced to only 2 years. For processing and recycling projects, this period will be only 1 year, which is considerably shorter than the existing situations. In addition, there are other proposals in order to mitigate the risks associated with the disruptions of the supply chain of raw materials. For instance, large companies will be audited every 2 years to show and demonstrate the resilience of their supply chain strategy. They need to provide the mapping of the supply chain of raw materials from recycling or extraction to processing, and then also demonstrate a stress test in which they assess the vulnerability of their system against some fictional supply chain disruptions. This act also envisions the improvement of monitoring and control of stocks of raw materials in Europe. Benchmarks are defined for each raw material stock, and then public authorities and publicly owned companies will be asked to report their stocks, both in terms of tonnage and the percentage of national annual consumption. There are also quite sophisticated and detailed frameworks in order to define how the stocks will be coordinated or maintained at some acceptable level.
Okay, understood. So, moving on to sort of the implications for automotive components, what are the raw materials affected on the propulsion side, for example?
Yeah, as the Act will apply to the materials deemed in two categories, like strategic raw material and critical raw materials. So, overall, the strategic raw materials refers to the resources whose current production is difficult to increase and for which demand is expected to grow significantly in the long term, meaning a shortage of those could derail the economic activity in shorter term, as they are of high importance to the EU economic and difficult to obtain. Specifically, the key motor components used in today's EVs comes under strategic raw material category and referring to the key motor components of the electric vehicles, which are magnets, windings, rotor, and stators. The main elements used in them, such as copper and rare earth elements, have been the main strategic raw materials under those categories.
Right. And so, how significant will the impact of the legislation be for magnets then?
Uh, Basically, critical to the raw materials, the latest S&P motor forecast suggests that about 89% of the motors being used in EVs are based on the permanent magnets, which represents a huge dependence on the magnets. And these materials typically contain several earth materials such as neodymium and dysprosium, both of which have a very geographically constrained supply chain and volatile price history. Whilst they are relatively small quantity in the motor, they can make up a significant portion of the cost of the motor. Also, recent design development from the OEMs for the permanent magnet motors to increase the overall efficiency, which can further increase the range, strengthens the magnet position as the critical raw material in the near future. On the other hand, we are seeing some of the manufacturers like Renault using the motors with the no magnets. Recently, Tesla also announced the same in their investor presentation. And these among the non-rare earth permanent magnets invented so far, only two of these large-scale productions, such as ferrites and other type being called as the alnico, which are aluminum, nickel, cobalt. But the problem with them is that these magnets are weak, and more important, the world supply of the cobalt is so fraught that they make up less than 2% of the permanent magnet market. Additionally, a key performance indicator of the permanent magnet is the maximum energy product, which is measured in the mega Gauss oersteds, or MGOEs in short. It reflects the both strength of a magnet as well as its coercivity. For the type of the neodymium iron boron commonly used in the automotive traction motors, the value is generally 10 times against the best ferrite magnets. This means the motor size can be a huge constraint for their developments. And this also raises the bar for their competence against the permanent magnet motors.
Right. So then neodymium is probably the more preferable choice for magnets then. I mean, that's certainly not the first metal that comes to mind when I think back to high school lessons on the periodic table. I mean, can you explain a bit for the layman's and for me, really, what neodymium is?
Right. Many of us basically don't hear neodymium, but we're probably carrying some of it around us in everyday lives. It's in our cell phones, headphones, and many of us have them in the car, probably driving around a Toyota or the Tesla Model 3. But broadly, if you combine neodymium, which is a rare earth material, with iron and boron, you can get a neodymium iron boron magnet, which is the most powerful type of magnet ever created. And magnets supplied in synchronous motors often consist of 10% of dysprosium as well, which helps in further improving the coercivity and the temperature tolerance. So that means they can be physically really tiny, but still strong for the motors being permanent magnets, having powerful, efficient motors that use fewer electromagnetic components.
Right, understood. Thanks for that breakdown. And moving on to another component, and probably the most significant for the industry really moving forward, is batteries. What materials are impacted by the act for them?
Okay, so in CRMA, key battery materials such as nickel, cobalt, manganese, lithium, and copper are included as strategic raw material. Regarding graphite, which is the dominant choice for anode, on the other hand, only the natural type is included. So to explain to the audience who might not be familiar with this topic, graphite can have two different types of sources, the natural and artificial. Natural graphite usually has slightly higher energy density, but poorer cycle life. So in this act, only the natural graphite is incentivized. So we need to see how this focus on natural graphite will shape the industry in the years to come. On the other hand, the cathode and anode active materials are not included in this legislation. We need to wait and see how things will pan out and see whether the production capacity of these materials will be expanded naturally as a business case without the incentives.
Okay. And then for the battery materials that are named in the Act, I mean, firstly, it'd be good to know what are the current demands for them and how will they develop?
Based on our current forecast, the demand for the batteries will skyrocket in the light duty sector. So in Europe alone, the demand for batteries will increase from 100 gigawatt hour in 2022 to more than 850 gigawatt hours in 2030. This means an eightfold expansion in just 8 years. So as you can imagine, this skyrocketing demand will severely strain the upstream supply chains, from raw materials to the machines that you need to build the gigafactories to even the human resource that you need in the upstream markets. Specifically about the raw materials, last year, in response to the increasing demand, we launched a dedicated forecast that tracks the selected raw materials from the mining all the way to the cell manufacturing, considering all the processing steps across the way. We also in frequent discussion and contact with our colleagues in the commodity insight and the market intelligence. Based on their forecast, lithium will observe a partial deficit in the short term, and that will only exacerbate in the next years in this decade. Fortunately, high prices have already incentivized the investment in this field, but still there is a fierce competition between the market participants in order to win this source that has become really competitive. Car makers and cell producers have started from setting long-term contracts or setting offtake agreements, but now they want to even directly engage in the mining business, as we saw with the acquisition of Lithium Americas by GM. Nickel has a quite different story than lithium because there are alternative chemistries that don't require nickel in them, unlike lithium. So, in recent years, we have seen a trend towards iron based chemistries like LFP or LMFP that don't require any cobalt and nickel, that can alleviate to a degree the need and the shortage of these materials. But still, on the longer time frame, our colleagues in market intelligence forecast a deficit in 2027, and the prices, we should remember that, are not as enticing as the lithium. So the investment in this particular field has more risk associated to it that will not really help the situation.
Right, that's good to know. Provides great context for my next question, which I wanted to lead on to, which is, we know there's an inherent risk of sourcing some battery materials. Could you detail some of these and, more importantly, how the Act can help mitigate those risks?
Yeah, sure. So Europe is not naturally gifted with the mineral resources, and as a result, historically, it has been reliant on other regions for the source of raw materials. So there are several risk factors associated with this regime. One issue is that when it comes to the battery raw materials, there's a monopoly of some countries over the supply chain of those materials. For instance, majority of cobalt is coming from Democratic Republic of Congo. This means any disruptions in that country will have a severe consequences on the downstream markets, including battery industry. China also dominates the majority of the processing of the battery raw materials. And due to the ongoing tensions, geopolitical tensions between the West and China, this over reliance over the Chinese produced materials can be problematic and reduce the resilience of the European battery supply chain. So, the Critical Raw Material Act can help mitigate these risks in various ways. So, there are projects like the JADER, a lithium deposit in Serbia that has been halted due to lack of obtaining the environmental permitting. So CRMA can help reignite those projects in Europe. And then also there are stipulations to facilitate the access to the capital for those projects. Recycling is another area that has been strategically emphasized in Europe. So we have to remember that with the current technologies like the hydrometallurgy, you can achieve 95% of recovery rate for recycling. So this means when we reach to a steady state production of EVs and we have passed this ramp up phase, essentially Europe can source these materials from recycling. But we are quite far away from that point. We need to wait 2 or 3 decades in order to reach to that steady state point. But still, even with the small level of feedstock that exists now from the production scrap or the end of life batteries, we see a surge of new projects in the recycling business in Europe. And this 15% target that I mentioned for 2030 will incentivize even further these sort of projects.
Right. Okay, brilliant. Thank you. And then, Piyush, going back to our neodymium, how well distributed is the material? I mean, is it easily obtainable in Europe?
Yeah. Basically, when we speak of these critical rare earths, such as neodymium, they are generally well distributed compared to the other strategic EV materials, such as lithium and cobalt. But the richness of these ores for these various materials varies greatly across the deposits, and many having only low levels of most useful and costly elements. Based on the current levels, China control about 90% of the commercial rare earth production. In China, the rare earth value chain is considered to be highly strategic asset to secure a growing market share in the major downstream and industry ecosystem. And Chinese rare earth magnet prices are government controlled and follow a strategic cross value chain. Long term rationale that aims to take leadership in a key downward industrial sectors. The Chinese control can be seen from the fact that about 16,000 tons of rare earth permanent magnets are exported from China to Europe every year, which accounts for about 98% of the European market. Another aspect problematically is that some of the most mineral wealthy countries have political and economic instability. And other countries, including United States, Australia, and others, are capable of developing reserves that could change this supply chain situation. Currently, it's a long road. And even there are significant reserves in Europe, but no mining takes place as of now, considering the size of the demand that is there for the EV. And with this act in place, European rare earth industry should be able to deliver about 20% of the European demand, reducing their dependence on China. And when we talk about the market aspects, there are few pointers like EV uptake increases globally, and the total motor production is expected to exceed about 34 million units by 2034, as per our data. And although there are potential concerns on the availability of rare earth and the cost associated with it, the magnet-based motor technology is likely to be the most preferred form of technology due to its high efficiency. There are already some shift away from the rare earth dependency, like Tesla and BMW being the big drivers of this technology, with the usage of induction and externally excited motors. Tesla recently announced it as well in that they would be making the zero rare earth motors, and also there are current excited synchronous motors forecasted to grow in the later part of the decade, with BMW and Renault leading the efforts of the motor technology without rare earth elements in them. So holistically, if you see that as on the market share basis, we project that from 2023 to 2028, permanent magnets are going down from about 89% to 79% because of the considered developments alongside, and maintaining the same proportion by 2033. But the fact that the motor market demand is going to increase up to 14x by 2038 and then further to 36x by 2034 of the current production levels predicts that the demand for neodymium is suspected to increase significantly only in the absence of any other promising technology. And that's being the reason that we are focused on new researches into the supply chain and technical aspects of rotors and stators of the motors, with a more focus on rare earth elements usage in them.
Okay, understood. Thank you. And before we wrap up today's episode, I mean, it may be worth noting that some of observers, some people may say that the EU's Critical Raw Materials Act is similar to that of the US's Inflation Reduction Act. How do you think they compare, or do you think the EU's act is a good response to its US counterpart?
So compared to the US, the financial means of European Union are quite limited. Inflation Reduction Act has quite generous incentive mechanisms for various levels of the supply chain, from the consumers to even the cell manufacturers and the raw material producers. So the consumers in the EV sector will benefit from $7,500 tax credit if the electric car that they purchase can satisfy the component and the raw material criteria. There's also an advanced manufacturing tax credit that has considerations for the cell manufacturing tax credit. So the cell makers would benefit from $35 per kilowatt hour tax credit, which is basically more than 30 or 40% of the overall cost of cell production. The material companies like the cathode active material or the lithium or nickel refiners will also benefit from 10% tax credit. So in contrast, the Critical Raw Material Act does not have direct financial incentives. They just provide the facilitation to access to the capital. And then their incentives are also limited to the raw material extraction, refining, or recycling. And some other levels of the supply chain, like the cathode and anode active material production, or some other components, are not included. Similarly, the battery cell and module production is not incentivized in this act. So, although there's already a good business opportunity in Europe to build a gigafactory, we have seen a sort of strong focalization of investments in North America for battery cell production since IRA was rolled out last year. Without similar incentives in Europe, there's a risk that North America will lure some of the projects that were supposed to be in Europe alternatively.
Right. Okay, understood. Thank you. And unfortunately, that's all we have time for today. A big thank you to you both for joining Autology.
Thank you, Elisha. Thank you for having us.
Thank you, Elisha.
No problems. And thank you to all you listeners for tuning in as well. We'd love to hear your thoughts on today's episode at our Autology at spglobal.com email. And you can find out much more at autotechinsight.ihsmarket.com. Don't forget to hit all the subscribe, follow, and like buttons to stay on track with the latest Autology podcast. And we look forward to you joining us again in the next episode. Bye for now.